welcome back to the lecture number 2 of chapter 8, that is quadrilateral. In its first lecture, we have discussed about what is a quadrilateral. Okay, what are the basic terms of quadrilateral such as angles, vertex as well as sides. Except this, we have discussed what are the consecutive sides and what are the non-consecutive or opposite sides. And in this lecture, we will discuss another term that is known as diagonal. Okay, so let us first understand what is a diagonal for a polygon, right? So let us first understand the meaning. A diagonal is a line, it is a straight line, okay, which joins two non-consecutive vertex. Okay, we know already what is non-consecutive vertex. So let us write the definition first. It is a line, a diagonal is a line which joins two non-consecutive vertex, or in the plural form we can write vertices. So a diagonal is a line which joins any two non-consecutive vertices. Okay, so if this is a quadrilateral, A, B, C and D. So in order to find the diagonal, we have to first find what are the non-consecutive vertex, right? If we consider the vertex A, right, then what are the consecutive vertex of A? Vertex B and this vertex D. So these two are consecutive vertex, but we are in the search of non-consecutive vertex. So A and C have no interconnection between them. That is why A and C are known as non-consecutive vertex. Okay. So in order to draw a diagonal, we have to simply join these two non-consecutive vertex. Now this is a diagonal. AC is a diagonal. Do you understand it? So let's write. Here AC is a diagonal, AC. Okay, let us find if any other diagonal is possible for a quadrilateral or not. Let us check. If we consider the vertex B, then what are the consecutive vertex of B? This vertex and this vertex. So these two vertex are consecutive. So this vertex D has no interconnection between B. That is why B and D are two non-consecutive vertices, right? So B and D are two non-consecutive vertices. That is why in order to find the diagonal, we have to join these two non-consecutive vertex. So what is the name of this diagonal? Now the name of the diagonal is BD, right? Next, do this quadrilateral has any more diagonal? Let us find. For example, we consider the vertex C. So what are the consecutive vertex of C? Vertex B and vertex D. So vertex A is the non-consecutive vertex. So let us join them. Already we have joined. See, already we have joined A and C. So there is no meaning to again join C and A. Understood? Similarly, if we consider the vertex D, then D and B are two non-consecutive vertex, and we have to join them. But we have already joined. So we need not to join these two vertex. Hence, what we find? We find a quadrilateral has as a whole two diagonals. Okay, since it is a quadrilateral, and whenever we join any two non-consecutive vertices, then we find individual diagonal. Understood? Now there is also a formula of finding the number of diagonals. So what is the formula? Let us understand the formula. The formula of finding the number of diagonal, okay, of a polygon is n into n minus 3 divided by 2. This is the formula. You can write it down. If there is any polygon, not only the quadrilateral but also any type of polygon, for example a pentagon, a hexagon, a heptagon or octagon, then this formula is suitable for any polygon. By using this formula, you can find the number of diagonal. Okay, so in this formula, as you can see, the formula is n into n minus 3 by 2, where n means number of sides. A polygon has how many sides? Okay, so let us verify it for the quadrilateral. Okay, right. Since for quadrilateral it has how many sides? It has 4 sides. So for quadrilateral n is 4. Now we will find the number of diagonals. Number of diagonals. Since the formula is n into n minus 3 by 2. So here in this place of n we can substitute 4 since it is a quadrilateral, right? By 2 is equal to 4 into 4 minus 3 is 1, by 2 is equal to 4 by 2, hence we get 2. See, here also for quadrilateral we get there are 2 number of diagonals. If it is a pentagon, pentagon means if the polygon has 5 number of sides, then how many diagonal is possible? So using the same formula, here in the place of n we can substitute 5. So 5 into 5 minus 3 by 2, that is 5 into 5 minus 3 is 2, by 2 is cancelled, 5. Hence we find that a pentagon has as a whole 5 number of diagonals. So if you want, then you can draw a pentagon and find its diagonal graphically or figurally. How? Let's see. Suppose it is a pentagon having how many sides? 1, 2, 3, 4, 5. Right? Name them A, B, C, D, E. What is a diagonal? A diagonal is the line which joins any two non-consecutive vertex. Now, what is the consecutive vertex of vertex A? E and B are two consecutive vertex of A. That means except A and B, there are also another two vertex, and these two vertex are non-consecutive vertex of A. Okay, so you can join A with D because A and D are non-consecutive. You can join A with C because A and C are non-consecutive. So how many diagonals here we find? We find 2. Again, let us consider the vertex E. What is the consecutive vertex of E? A and D. Now the non-consecutive vertex are C and B. So let us join E with B and E with C. So how many? Again we get 2. Right? 1, 2, 3, 4. Next, let us consider the vertex D. So what are the consecutive vertex of D? C and E, and non-consecutives are B and A. So let us join A and B. Already we have joined A with D. Now let us join the remaining one, D with B. So here we get another one diagonal. Next, if you consider the vertex C, then the consecutives are B and D, non-consecutives are A and E. But already we have joined C with A, C with E. So no need to again draw it. If we consider the vertex B, then consecutive vertex are A and C. Non-consecutives are E and D. Already we have joined BE and BD, so no need to join again. So as a whole, what I get 2 plus 2 plus 1, that is 5 number of diagonals. So figurally I have found that a pentagon has 5 number of diagonals, both calculation wise and both graphically. Understood? So this is the concept about how to draw the diagonal. Now as you can see, in case of either quadrilateral or you can say pentagon, in this case what you get? We get the diagonals are formed inside the figure. Here also you can see the diagonals are formed inside the figure. Here it has two diagonals and the two diagonals are inside this figure. They are not outside the figure. Okay, but let us draw one more diagram. Let's say this. A, B, right? C, this is C, this is D. Tell me, is it a quadrilateral? Find it. How many sides it has? A B, BC, CD, DA. So it has 4 sides. Second thing, is it closed? Yes, definitely it is closed, because any point inside it cannot move outside. Okay, or there is no space so that we can move outside from the inside. So it is a closed figure. So it is closed figure. It has four sides. All the sides are straight lines. That is why it is also a quadrilateral. It is also a quadrilateral. Now, let us find the number of diagonals it has. We know definitely a quadrilateral has two number of diagonals. Let us draw them. The diagonals are the line which joins any two non-consecutive vertex. Now find the non-consecutive vertex of vertex A. Okay, how we can find? For this we have to first find the consecutive vertex. The consecutive vertex of vertex A is, see, this vertex and this vertex. Because this vertex has two arms, this arm and this arm. Now this arm is related to this vertex, this arm is related to this vertex. So the non-consecutive vertex of vertex A is vertex C. So we have to join A with C. So this is the first diagonal. So the name of the diagonal is AC. Right. Let us find the second diagonal. For this we have to consider another vertex, that is vertex B. Now let us find what are the two consecutive vertex of vertex B. As you can see, vertex A and now vertex C are the two consecutive vertex of vertex B. But we have to find the non-consecutive vertex. Okay, so this vertex D, which is the remaining vertex, is the non-consecutive vertex of vertex B. So in order to find the another diagonal, we have to join any two non-consecutive vertex. So let us join this vertex with vertex D. Now this BD is our another diagonal. Understood? Now we have found two diagonal for the quadrilateral ABCD. Now look at this figure vividly. As you can see, in this figure the diagonal AC, right, lies inside this figure, isn't it? Here the diagonal AC lies inside the figure, but the diagonal BD lies just outside the figure. If this is the enclosed space of the figure, suppose this is the figure, now you can see this line BD, this is the diagonal, and this diagonal just lies outside this figure. It lies outside this figure. Understood? So it is a type of quadrilateral in which at least one diagonal out of the two diagonal lies outside the figure. But look at this figure. In this figure both diagonals lies inside the figure. If you take another quadrilateral like this, like trapezium, then here also these two quadrilateral, these two diagonal lies inside the quadrilateral. But here in this case, one diagonal lies inside and one diagonal lies outside. That is why this type of quadrilateral is completely different from this type of quadrilateral on the basis of diagonals. And on the basis of diagonals, the quadrilaterals are of two types. What are they? They are known as convex quadrilateral, and the second one is known as concave quadrilateral. Okay, if you want, then you can write it. So what is a convex quadrilateral? A quadrilateral in which the two diagonal lies inside the figure. Two diagonals inside the figure. Okay, like this. In this type of quadrilateral, the two diagonals lies inside this figure. That is why this type of quadrilateral is known as convex quadrilateral. So it is a type of convex quadrilateral. Since here all the two diagonal lies inside the figure. This type of quadrilateral is also known as convex quadrilateral, because here the diagonals lies inside the figure. Understood? Then what is the meaning of concave quadrilateral? A quadrilateral in which at least one diagonal lies outside the figure. Okay? One diagonal outside. Okay? So a quadrilateral in which one diagonal lies outside the figure like this is known as concave polygon. Okay, you can write the definition. Since the shortage of spaces I cannot write, So if you want, then you can write the definition of convex and concave quadrilateral. Okay, so a quadrilateral in which any one diagonal lies outside the figure, then such type of quadrilateral is known as concave quadrilateral, and in quadrilateral in which both the diagonal lies inside the figure is known as convex quadrilateral. Okay, so quadrilateral are of two types on the basis of position of the diagonals. Understood?